Good day, my dear students. This is Simplified Physics and Maths, and today I would like us to look at resolution of vectors, which is under physics. Resolution of vectors. Alright, so let's begin by this. Let's say you are walking up on a staircase. So let's say this is our staircase. You are walking up on this staircase. Now, as you move up the staircase, you have a horizontal displacement over here, and you also have a vertical displacement over here. How do we know that? Let's say as you move up the staircase at a certain point here, let's call that A. If you trace it down, you get it, let's call this A1. At a certain point B, let's trace it down, B1. At a certain point C, let's trace it down, C1. So you see, as you move up the staircase, you realize that there is a horizontal motion over here. And not only that, you can also trace this side to this side, and you get, let's call it A2, the B, let's trace it to this side, you get B2. Let's trace the C2 also to this side, you get C2. So as you move up the staircase, you also have your motion is also directed vertically over here. There is a vertical displacement over here. So what are we saying? As you move along the staircase, there is your actual displacement. This actual displacement has a horizontal displacement and a vertical displacement. Remember, displacement is a vector quantity. So this particular vector has a horizontal component and a vertical component. So the idea of splitting a vector into its horizontal component and vertical component is what we call resolution of vectors. Let me repeat what I just said. I'm saying that as you move along the staircase, up the staircase, we have a horizontal displacement over here. You also have a vertical displacement over here. So it means your actual displacement has two components, a horizontal component and a vertical component. So splitting a vector into its horizontal component and vertical component is what we call resolution of vectors. Okay, so let's quickly do something over here. What I have drawn over here, we can make, so this is the staircase. This is our horizontal component and this is our vertical component. Now let's call the actual displacement as A. Your actual motion. Then let's call the horizontal displacement as AX. Let's call the vertical displacement as A subscript Y. A subscript X and A subscript Y. We can bring this side because they are all parallel. So if this side is AY, A subscript Y, here will also be A subscript Y. You can also create this side to this point. So if this side is A subscript X, this side will also be A subscript X. Now, the angle that the displacement makes with the horizontal, let's call it theta. So theta is the angle that the vector A, which is the displacement in this case, makes with the horizontal. So by using the idea of SOHCAHTOA in trigonometry, the idea of SOHCAHTOA, which we say, so it's sine theta opposite over hypotenuse, cos theta adjacent over hypotenuse, tan theta equals to opposite over adjacent. The hypotenuse is always the longest side. The opposite can be determined by looking at where the angle is. So if the angle is here, then the opposite is this side. If the angle was here, the opposite will be this side. So quickly, let's find from the right angle triangle over here. Let me call it ABC. Let's find sine theta. Sine theta from triangle ABC, right angle triangle ABC, sine theta opposite AY all over the hypotenuse, which is A. So if I make AY the subject, I get A sine theta. Then let's also find cos theta. That is adjacent over hypotenuse. So adjacent is AX all over the hypotenuse, which is A. So if I make AX the subject, I get A cos theta. So what's the summary here? The summary here is, if you want to split, or if you are given a vector, that particular vector has two components. We have the horizontal component and the vertical component. The horizontal component is given by AX equals to A cos theta. And then the vertical component is given by AY equals to A sine theta. So that is how you calculate, or these are the formulas that you will use to calculate the horizontal and vertical component of any given vector. Any given vector at all, displacement, force, any given vector. You can use this formula to calculate the horizontal component and then the vertical component. So let's take this example. Let's say a force of 20 Newton is making an angle of 30 degrees with the horizontal. So this is my force, 20 Newton, which makes an angle of 30 degrees with the horizontal. And then we are asked to find the vertical and horizontal component of this force. How do we go by it? You can simply use the formula that we just derived. So our formula for the horizontal component is given by AX equals to A cos theta. Since we are dealing with force, let's use F. Remember that I use A. It's not by force to use A. You can choose any, alphabet at all. So since we are dealing with force, let's use F. So F X equals to F cos theta. Remember, theta is the angle the vector makes with the horizontal. So in this case, we have been given that angle to be 30 degrees. So Fx is equals to F is 20 cos the angle is 30 degrees. So Fx, so you just want your calculator. Now cos 30 is the same as root 3 over 2. So if you solve this, cos 30 is the same as root 3 over 2. So in place of the cos 30, you just put root 3 over 2 there. So if you solve this, 2 goes here, 1 goes here, 10. So 10 root 3 Newton for the horizontal component. Then the vertical component to Fy, the vertical component Fy will be equals to F sine theta. So Fy is equal to, the force was 20, the angle was 30 degrees. So Fy, now sine 30 is the same as half. So 2 goes here, 1 goes here, 10. So 10 times 1 is the same as 10. So our vertical component is 10 Newton. So that is just a simple example about what we did today. As time goes on, we are going to take more examples. So today we have seen that we can resolve, or we can split vectors into horizontal component and vertical components. And the idea of splitting vectors into horizontal component and vertical component is what we call resolution of vectors. We have also seen that if you split a vector into its horizontal and vertical components, you have the vertical component given by AY equals to A sine theta, and the horizontal component, which is given by AS equals to A cos theta. God willing, if we meet next time, we are going to talk about how to find the direction of vectors. Thank you very much.